And today we're going to take a look at the process of building a lag interface between two devices. What I'm showing on the screen is a simplification of our environment. We've got Ruckus 1 and Ruckus 2. We also have 3 physical connections between them. Those are the connections that I want to use to build this lag interface. For the purposes of this demonstration, the configuration on the Ruckus 2 switch has already been completed. It is configured as a dynamic lag with all the proper ports on that side. However, we don't have any of the configuration on Ruckus 1, so that's what we need to do today. If we take a look at our Ruckus 1 switch, we can see that, as I said, there is no configuration on it. We don't have a lag interface. We don't have any virtual lag interfaces. And if we look at our actual interface status, all of our interfaces are down or disabled. So the first step that we need to do is actually go ahead and create that lag. The way that we begin that is by the lag command. So from config mode, we enter in lag. We then enter in a lag name, and I'm just going to simply call this Ruckus lag, all uppercase. And then we need to specify the type of lag. So I said the device Ruckus 2 had a dynamic lag, and we need to match that. So we're going to make this a dynamic lag as well, and we're going to give it an ID of 1. We could choose auto here, but I like to assign my lags so I know kind of sequentially where I am. It's just how I like to do things. It would work either way, however. So once we've got that command defined, we can press enter, and we're taken into the lag configuration context. This is where we need to start adding those ports into the lag. So again, I said I had 3 connections already ran between the devices, and they are ports 9, 10, and 11. So what I need to do is I need to add those into this lag. So I'm going to add ports, Ethernet, and I'm going to do 119 to 11, well, not 10101, 1111. So this will add those ports to the lag, and we are given a message that says, hey, you know, those ports were deployed successfully. With those ports successfully added, I do want to pause here and just kind of show you some things that could go wrong. I have a port that is, I know it's misconfigured. It would be port 8. So if I try to add port 8 to this E118, we're going to get a message that, hey, you can't add this because it's not in the same VLAN as these other ports. So when you're building this out, you do need to make sure that the VLAN configuration for tagged and untagged VLANs matches before you're actually going to be able to add that port into the lag. The same thing is true when we're talking about mismatched speeds. So you can mix a 1 gig and a 10 gig port, but you have to set the kind of the base speed here. So if I tried to add ports Ethernet 132, which is a 10 gig optical interface, it's going to fail. It's going to say, hey, you know, this thing is kind of configured as auto mode and it's optic based. That's not going to work. What we can do to kind of get around that, if we wanted to include that 132 10 gig interface, we could go in and define the speed duplex for this lag interface. And we're going to go ahead and do that. We're going to go into interface vlag 1, which is created. I'm sorry, I said vlag. It's interface lag 1. And that's going to take us into our virtual lag interface. Now what we need to do is we need to do a speed duplex command to kind of establish what the baseline for this particular lag should be. And this is basically setting our anchor speed. So the anchor speed is something, if you don't define it here, it's going to be defined based on the first port in the lag to come operational. It's a good idea to go ahead and set that anchor speed within the VLAG context so that even on a reboot or if some ports go up or down, you don't have an issue where the lag comes back up with a speed that is going to cause all of the other members to kind of fail and go into operation mismatch mode. So with that speed defined here, I then can go into that 132. So if I go into interface E132 and I set the speed duplex on that as well to 1000 full. That is done. Now if I go back into my lag, Ruckus lag, I should be able to add ports Ethernet 132. And it didn't complain. It likes that. So now that all of that speed duplex matches, we've got the operational speed defined, it's fine to add that into the lag. And it would operate perfectly. There was no issue with how that's working. However, we are kind of sacrificing the 10 gig capabilities, and it is only going to run at 1 gig. So typically you wouldn't want to do that, but in a pinch, know that it can be done. I'm actually not wanting to add that port, so I'm going to take it out with the no command. And you can see that when we removed it, it actually disabled it automatically. I think it was disabled anyway, but this is something that happens in the lag configuration so that you know you're not creating a loop when you're removing things from the lag. Another configuration that I want to apply to this is an LACP mode. I'm actually going to put this temporarily in passive mode so we can kind of take a look at what that means. So I think with the configurations that we have now, I should be able to try to bring this lag online. Now again, remember when we did the show interface brief, ports 9, 10, and 11 are offline. What I need to do is actually bring them online. And I cannot do that from the context of the physical interface. I cannot go into port 119 and do an enable. I actually have to do a ports and Ethernet. Actually, I think I have to be an enable. Yes, enable. Enable Ethernet E119 to 1111. So I'm enabling all 3 of them at once. With this command, I could do them one at a time. And I'm not, I lied. It's already defined Ethernet. So I did Ethernet, 119 to 1111. There we go. Okay, so at this point, if we look at show interface brief, we should see those guys coming up, and they are saying that they are blocked, and we can see that even LG1 there, so that's our virtual lag interface there at the bottom, it is showing up and blocked as well. I'm going to keep refreshing this command to kind of see what we have, and we just see that it is just blocked. Another thing that we can take a look at is our actual lag. So we can run the command show lag and kind of see operationally what's going on with this guy. And if we look at our output here, we can see under the OPE column or the operation column, we have inactive. This is meaning that we're not actually we're not up. We're not exchanging LACP. We're not having a good time. And if we look down at our PDU statistics, we can actually see that there is no LACP received or transmit. And I'll tell you why that's interesting. So we put in LACP as passive mode, which means that it's only going to listen for LACP data units. It's not going to try to send any out. Well, if the other end of our lag connection is also set to passive mode, then basically both ends of that link are just listening and never initiating. And I do have that other side of the link configured as passive. So what I actually need to do is I need to go back into my lag configuration and change that. So I'm going to say no LACP mode passive. And it'll take a second maybe for that to flap. And we should be able to run show lag again. And we can see automatically it came back up as operational OPE. And we see that LACP receive and transmit count now going in between them. So if we look at show interface lag 1, we can see that this lag now is online. We can see what ports are a member of this lag. We can see, kind of the utilization on it. We can see, all of the interface statistics about this lag. Then again, if we look at show interface brief, we can see that 9, 10, and 11 are up, and LG1 is up, and everything is forwarding. So, in this case, we were able to build a successful lag with those three links. And if you follow